Welcome to your 8th grade physical science forces exam. Question 1. It takes more force to accelerate a bowling ball than a golf ball. Which law would this best represent? So which would be the best representation? Law 1, Law 2, Law 3, Law of momentum. Question 2. Identify what each of the following abbreviation measures. That means for 5 meters per second squared. What does that measure? Kilograms. What's that a measurement of? N. What are we measuring in? Is it time, mass, and inertia? Speed, inertia, and force? Inertia, acceleration, and velocity? Or acceleration, mass, and force? Which of these has the least inertia? A semi-truck, a turtle, compact car, a feather. What is the net force on the box below? So remember how we calculate net force. Remember what we do when it's going in the same direction. What math do we use? What math do we use when it's going in opposite directions? 50 newtons to the left, 10 newtons to the right, 50 newtons to the right, or 10 newtons to the left. Due to gravity, Earth is pulling down on a book with a force of 4 newtons. According to Newton's third law, what other force must be happening? The book is pulling up on Earth with a force of 4 newtons. Earth is pulling on the book with a force of 4 newtons. Earth is pushing up on the book with a force of 4 newtons. Be careful and notice what the sentence said. Earth is pulling down. So the choices are the same, A, B, and C. Newton's second law of motion states that relationship of mass, acceleration, and force. It states that force equals acceleration divided by mass. Force equals mass times acceleration. Every object attracts another object in the universe. Or force equals mass divided by acceleration. A Ferris wheel turning on its path at a constant speed of 3 meters per second, therefore, it is not accelerating. False, the Ferris wheel is turning, therefore it's accelerating. True, the Ferris wheel is changing direction. False, the Ferris wheel is moving forward, therefore accelerating. Or true, acceleration must have a change in speed or direction. So the sentence said it's not accelerating. Consider Newton's first law of motion to determine which of the following statements are true. Check all that apply, which means there's more than one answer and it's worth 2 points. Newton's first law of motion is applicable to both moving and non-moving objects, means that it applies to both. If an object's at rest, then there's no forces acting upon the object. It is a natural tendency of all objects to eventually come to a rest position. It would take an unbalanced force to cause an object to accelerate from rest. Which of these, more than one, is true? You're waiting in line to use the diving board at your local pool. While watching people dive into the pool from the board, you realize that using a diving board to spring into the air before a dive is a good example of Newton's third law of motion. Explain how a diving board illustrates Newton's third law of motion. You put force on the board and you move. Resting objects move. The action force is the force you put onto the board, and the reaction force is the board puts back on you. The more force you put on the board, the higher you jump. F equals m times a. This does not illustrate Newton's third law, only the first law. Okay, back to the net force. Remember what you do when they're going in the same direction or they're going in the opposite direction. Oh, I'm sorry. This is calculating net force. So you're just finding force, mass, or acceleration. A net force of 50 newtons acts on a cart, causing it to accelerate at 2.5 meters per second squared. What is the mass of the cart? So this is our calculation triangle and what you're looking for. 125 kilograms because mass equals force times acceleration. 0.05 kilograms because mass is always smaller than the force. 25 kilograms because you subtract acceleration from force. Or A, which really should be D, 20 kilograms because mass equals force divided by acceleration. So 50 divided by 2.5 equals 20. Number 11, an orange might roll off your cafeteria tray when you stop suddenly because of the orange inertia, friction forces acting on the orange, balance forces acting on the orange, or air resistance acting upon the orange. Which answer below correctly identifies the net force in this picture? So we have 85 north, 85 south. So those are up and down. And you have 65 to the left and 70 to the left. I'm sorry, to the right. 65 to the left and to the right and 70 to the right. So what do we do when they're going in opposite directions, and what do we do when they're going in the same directions? 65 newtons to the left, 135 newtons to the right, 170 down, and 70 newtons to the left, or 5 newtons to the right. 13. A runner sprints forward at the sound of a starting pistol. A fire truck flies around the corner at 30 miles per hour. A school bus rows to a stop in front of the school. Which of these does not represent acceleration? The runner sprinting forward because he's speeding up. School bus rolling to a stop because it's slowing down. Truck going around a corner because it's not changing speed. Or none of these. They all represent acceleration. 14. A tablecloth can be withdrawn from under a container of milk without toppling it if the cloth is jerked quickly. The reason this can be done is that gravity doesn't affect the tablecloth, forces on the milk container and the tablecloth's inertia causes it to move, gravity holds the dish down and there's no force acting on the tablecloth, or forces on the tablecloth, the milk container's inertia wants to keep sitting still and gravity pulls it down. 15. Two students are pushing identical boxes. Student A pushes with twice the force that student B does. Assuming the boxes have the same mass and friction is the same for both, what will happen? A, both boxes will accelerate the same because the masses are equal. B, student A's box will accelerate twice as much because acceleration depends on both mass and force. C, student A's box will move faster only if he keeps pushing longer. D, neither box will move unless the force is greater than the box's inertia. 16. When a swimmer pushes backward against the water with her hands, she moves forward through the pool. Which explanation best shows how Newton's third law applies here? A swimmer moves forward because the water pulls her in the direction she wants to go. B, the swimmer moves forward because she exerts more force on the water than can resist. C, the swimmer moves forward because the water pushes forward on her with equal force as she pushes, and you have to kind of click it to see the rest. The swimmer moves forward because the water pushes forward on her with equal force as she pushes back. The swimmer moves forward because of her arms' reduced friction in the water. Use the picture to show and explain why the man flies out of the car. Choose all that applies. This is a 2-point question. There's more than one. The outside force was on the man, not the car, so he kept going. The man's inertia and velocity made the car stop when it hit the wall. The outside force was on the car, not the man, so his inertia kept him moving. The man's inertia had no outside force to stop him. Almost done. If a train is slowing down, it has momentum, but it's not accelerating. Which statement is correct? False. The train is changing direction, so it's accelerating. True. The train is slowing down, so there's no acceleration. False. The train is changing speed, so it is accelerating. True. The train is slowing down, so no momentum or acceleration. 19. When you know both speed and direction of an object's motion, you know the average speed of the object, the distance the object traveled, the velocity of the object, or the acceleration of the object. 5. The displacement time graph below shows the motion of a cart initially moving forward as a straight line. So we have a cart. It's going from A to B, B to C, C to D, and D to E. From A to B, the car is not accelerating. From D to E, the car is slowing down, so not accelerating. From C to D, the car is at a constant speed, not accelerating. Or from B to C, the cart is not accelerating. Which one of those shows that the cart is not accelerating? You can always stop, pause, and review this video. Good luck.